Welcome to this channel, and in this video we're going to be taking a question on differential equation, a simple one from Cambridge AS A-level math. Okay, so what we're given is cos 2x dy dx equal to 4 tan 2x over sine squared 3y. So what we basically do here is to group everything together, dy to y and dx to x. So you could see that there's a dx here. So you could move the sine squared 3y over and become sine squared 3y cos 2x dy dx is equal to 4 tan 2x. And then if we divide through by cos 2x, right, what we're going to have is sine squared 3y dy dx equal to 4 tan 2x over cos 2x, and then we could then move the dx over so that we just have dy on one side, dx another, and then every stuff there aligns. So that's 4 tan 2x over cos 2x dx, right? So that's it. So then to solve this, we then get the integral of both sides. So that's the integral of sine squared 3y dy equal to the integral of 4 tan 2x over cos 2x dx, right? And then the question is, what's the integral of sine squared 3y? And that's not difficult, right? And the use substitution won't help here because there'll be no cancellation, there'll be no way out here because of the two functions involved. So what we simply do is recalling the cos formula that says that cos A plus A is equal to cos squared A negative sine squared A. We could then relate that to this over here, and knowing that 1 plus sine squared A, plus cos squared A is equal to 1, right? So we could then say that cos squared A is 1 negative sine squared A, and then negative sine squared A. So that becomes 1 negative 2 sine squared A. So we can then relate that to this. In this case, we have sine squared 3y. So that's cos 3y plus 3y is equal to 1 negative 2 sine squared 3y, right? So that's it. So what we have is cos 6y equal to 1 negative 2 sine squared 3y. So our goal is sine squared 3y. So this then becomes 2 sine squared 3y is equal to 1 negative cos 6y, right? And then sine squared 3y is equal to 1 negative cos 6y over 2, right? Dividing 3 by 2. So we could then rewrite the integral as the integral of 1 negative cos 6y over 2 dy is equal to the integral of 4 tan 2x over cos 2x dx, right? So moving on, you can see that there's a quantity here, tan 2x, and you should know that tan 2x is equal to sine 2x over cos 2x. That's all from the formula that says that tan A is equal to sine A over cos A, right? So we could then replace that as 4 times sine 2x over cos 2x all over cos 2x. And that becomes 4 sine 2x all over cos squared 2x, right? So that leads us to something. So that's the integral of 4 sine 2x over cos squared 2x dx. And we could make a use substitution here because we know that if we should differentiate cos 2x, right, it has a link with the numerator, which is sine 2x. So we could simply say let u be equal to cos 2x, and by differentiation you know that du dx is equal to 2 cos 2 sine negative 2. Let me write it properly. That's du dx is equal to negative 2 sine 2x, because you know that differential of the cos function is a negative sign, right? And then with this, we can then say that dx is equal to du over negative 2 sine 2x. So with that, we can then write this as the integral of 4 sine 2x, right, all over u squared, because we said let u be equal to cos x, multiplied by du over negative 2 sine 2x. So this cancels, and then we're left with 4 over negative 2. That's going to be negative 2 over u squared du. So we could move the negative 2 over to become negative 2 integral of 1 over u squared du. And that's going to be negative 2 into u. 1 over u squared is same as u to the negative 2 plus 1 over negative 2 plus 1. Right? And that is negative 2 into u to the negative 1. Negative 2 plus 1 is negative 1. So negative goes with the negative, then we have 2u to the negative 1, which is same as 2 over u. So we've simplified that as 2 over u plus c. And then we then recall that u from the substitution is equal to cos 2x, right? So that's 2 over cos 2x plus c. Now let's tackle the left-hand side of the differential equation, which says 1 negative cos 6y over 2 dy, right? So in that case, we have 1 negative cos 6y over 2 dy. So we could move the half to the left side to become half integral of 1 negative cos 6y dy, right? So with this, it's simple. So if we should integrate 1 with respect to y, what we're going to have is half into y negative. If we should integrate this, we're going to have 1 over 6 sine 6y, right? That's via the u substitution. Maybe saying let u be 6y, and then du dy as 6, and then dy as du over 6. So that makes this 1 over 6 cos, right? And then if we should integrate cos, we're going to get sine, right? That's simple. So with this, the job is done. So we're going to have 1 over 2y negative 1 over 6 sine 6y is equal to the right hand side, which is 2 over cos 2x plus c. Notice that a plus c wasn't added here, because if we should take this as c1 and take this as c2, right, if we bring this over, right, as that becomes c2 negative c1, which is still a constant, and let's call it c, right? So, and then if you look carefully from the question, it says where 0 is less than or equal to x less than pi over 4 radians, and it is given that y is equal to 0 when x is pi over 6, right? So it says that y is equal to 0, right? So that's half into 0, negative 1 over 6 sine 0 plus 2 is equal to 2 over cos 2 into pi over 6 plus c. So all this is 0 is equal to 2 over cos pi over 3, right, plus c. And the cos of pi over 3 is half plus c, and that's 0 equal to 4 plus c. That means that c is negative 4. So we could then write generally that half into y negative 1 over 6 sine 6y is equal to 2 over cos 2x negative 4. So this is the solution. This is the general solution. The question now says solve the differential equation to obtain the value of x when y is pi over 6. So if we then replace that, that's half into pi over 6, negative 1 over 6 sine 6 times pi over 6 is equal to 2 over cos 2x negative 4, right? So then with this, what we have is pi over 6 times 1 over 2 is pi over 12, negative 1 over 12. This cancels this, and then we have sine pi is equal to 2 over cos 2x negative 4, right? So with this, if you get a calculator and simplify this. The sine of pi is 0, right? So all this here is 0. So what we have is pi over 12 equal to 2 over cos 2x negative 4. And remember that the goal is to get a value of x. So the value of pi over 12 is equal to 0.262, right? And that's equal to 2 over cos 2x negative 4. So we add 4 to both sides. It becomes 0.262 plus 4 equal to 2 over cos 2x. So that's going to be 4.262 equal to 2 over cos 2x, right? And then we could then multiply it through, and it becomes 4.262 cos 2x is equal to 2, and then dividing through by 4.262, we then have that cos 2x, that's 2 over 4.262, that's going to be equal to 0.469, right? 2. And then 2x will be equal to the cos inverse of 0.4692, right? The cos inverse of 0.4692, and that is 1.0824. That's in radians, because all these were meeting radians. And then dividing through by 2, the value of x is equal to 0.541, right? So to 3 decimal places we have 0.541, and that's the value of x when y is equal to pi over 6. Thank you so much for watching this vid. Remember to like, share, and subscribe to this channel.